Okay, let's dive right into this. Welcome to today's Explainer, where we're tackling a truly fascinating transformation. We're going to look at the exact anatomy of a room, specifically by demystifying standard CAD layers. It's always a challenge figuring out how to translate a beautifully designed space, the kind you'd present to a client with realistic images, into the precise, color-coded logic of a CAD floor plan. Well, our goal today is to break that all down and make this process incredibly intuitive and totally easy to understand.
Think about that for just a second. I want you to actually look around and visualize the physical space you're sitting in right now. How can we systematically strip that room down, literally layer by layer, onto a flat 2D drawing without it turning into a confusing, tangled mess of lines? How do we capture the reality of a space so that builders, architects, and designers all over the world can universally understand exactly what we're going for?
Well, here is our roadmap for this explainer. 1. The power of CAD layers. 2. The structural heavyweights. 3. Fixtures, furniture, and glass. 4. Invisible systems. 5. Information and finer details. And finally, 6. Cracking the color code.
All right, kicking things off with Section 1, the power of CAD layers, and why organization matters.
So a CAD drawing is fundamentally a vital communication tool. It's really not just a bunch of random lines floating around on a black screen. It is a language. And like any language, it needs grammar and structure to make sense. The golden rule here is simple. Clear layers equal readable prints and easy edits. A well-organized system is what makes complex blueprints super easy to understand, whether you're a first-year interior design student or a seasoned professional. Think about it. If everything was drawn with the exact same line weight and color, your blueprint would just look like a giant spider web. Layers literally give us the power of clarity. Moving right along to Section 2, the structural heavyweights, the bones of the room.
Okay, picture the unmovable structural bones of a building for a second. The concrete, the bricks, the massive things that keep the roof from caving in. Notice how CAD line weights physically represent the reality of those heavy objects? Columns absolutely command the drawing. They get a massive 0.40 millimeter line weight in red. Walls follow closely behind at 0.30 millimeters in black, and slabs sit right at 0.25 to 0.30 millimeters, also in red. Because these elements are the true physical heavyweights of the space, they get the heaviest, thickest, continuous lines on the paper. It ensures they remain highly visible and dominant.
But wait, there is actually one line that is even thicker, the section line. This indicates the cutting plane in section drawings, and it's highlighted in light pink at a staggering 0.50 to 0.60 millimeters. So the absolute thickest line in our entire hierarchy is the section line. Why? Well, because it doesn't just represent an object, it dictates the primary cut and perspective of the entire drawing. It screams out to the viewer exactly where we slice that space in half.
That brings us to Section 3, fixtures, furniture, and glass, the interior elements. Now we transition to the functional elements. The stuff that turns a cold, empty concrete box into a warm, lived-in space. Notice how we start dropping down in line weight here. Doors and windows sit at a standard 0.25 millimeters, marked in brown and a gray-blue mix respectively. But movable elements, like a plush brown sofa, they drop down to a sleek 0.18 millimeter brown line. Glass drops to 0.18 millimeters as well, but in navy blue. This hierarchy is honestly genius. It ensures your soft furniture doesn't visually compete with or overpower those heavy structural walls holding up the building. Now, you might have noticed a trend in the line types we've discussed so far. They are all continuous lines. A continuous line is simply a solid line used for visible objects, things like walls, doors, windows, and furniture. It reinforces a really simple rule. If you can physically see the object when comparing the blueprint with realistic images of the space, it gets a solid, continuous line. Makes sense, right?
All right, Section 4, invisible systems and networks, the concealed reality. As you know, a room isn't just what you see on the surface. We also need to document the hidden, vital organs of the space. Notice that electrical points, plumbing inlets, plumbing outlets, and beams all share a uniform, lighter 0.18 millimeter weight. Because all these overlapping systems can get super confusing, CAD uses intuitive color codes to keep them distinct. Red for electrical systems, think of live hot energy. Light blue for plumbing inlets, representing clean water supply. Dark gray for plumbing outlets, representing waste. Using these logical colors makes reading those complex invisible systems easy to understand.
So how exactly do we draw things we can't see, either because they're above us or buried inside a wall? We use a hidden line. This is a dashed line specifically used for overhead or concealed elements. Think about a big structural beam. In reality, it is definitely there in the space, but in a standard floor plan cut, it's hovering above our heads. The dashed hidden line perfectly communicates, hey, this object exists in the real room, but it's hidden from our current view. Let's move into Section 5, Information and Finer Details, the final polish. So we've built the walls, placed the furniture, and routed all the plumbing. Now we introduce the thinnest, most delicate layer of our CAD anatomy. This includes surface textures, material patterns, and crucial measurement data. Look at how incredibly thin these lines get. Flooring and tiling drop to 0.13 millimeters in light gray. Material hatches can go all the way down to an ultra-fine 0.09 millimeters, also light gray. Dimensions and center lines sit at 0.13 millimeters in black and green. And text is usually dark blue or black at 0.18. I kind of like to think of these as whispering lines. They use very lightweight strokes to add rich material representation, but without making the drawing heavy, cluttered, or difficult to read. And this brilliantly illustrates the entire core philosophy behind CAD line weights. On one side, you have the undeniable physical presence of a structural column drafted at a heavy, bold 0.40 millimeters. On the flip side, you have the lightweight detail of a material hatch drafted at a whisper-thin 0.09 millimeters. This hierarchy is exactly what prevents visual clutter. It instantly tells your brain what holds the building up versus what is just a pretty tile pattern on the floor. Finally, we've reached Section 6, cracking the color code for easy memorization. Let's consolidate all of this into a super easy to understand cheat sheet. Memorizing this actually makes CAD a breeze, mostly because it logically matches realistic materials. Black is for your primary definers, walls and dimensions. Red screams caution and structure, so that's your structural elements and electrical. Brown perfectly maps to wood, so naturally doors and furniture. Blue is pretty obvious, glass and water supply. Green is for center lines. Light gray fades right into the background, perfect for flooring and hatches. Light pink immediately draws the eye for section lines, and dark gray handles the messy stuff, like drainage. All of this builds into the ultimate master key for any aspiring draftsperson. It really just comes down to 3 easy steps. Step 1, organize by color for your screen view so you never get lost while drafting. Step 2, indicate purpose by line type. Use continuous lines for visible objects and hidden dashed lines for concealed ones. Step 3, control printing by line weight. Remember, the physical weight of the line dictates the entire visual hierarchy on the final printed page. Which brings us to our final thought for today. Armed with the anatomy of these standard CAD layers, you have the exact tools needed to bridge the gap between imagination and construction. By using these standardized hierarchies, literally any complex, chaotic reality can be tamed into an elegant, readable plan. So I'll leave you with this question. How will your next design clearly communicate its realistic vision on paper? Use these layers, keep things organized, and make it brilliant. Thanks for joining me on today's Explainer, and I'll see you next time.